And question 2 then, on the critical points in the graph of this function. Now the graph of this function is only going to be defined on this limited domain, this interval here, from 0 to 2, not including 0, the round bracket, but including 2, the squared bracket. So what should that look like? Well, it's a parabola, which is the correct way round, positive x squared term. These signs are opposite, so it's going to pass to the right, its axis symmetry is to the right here. And does it or doesn't it cross the x-axis? Well, let's just check quickly with the discriminant on that then. So I've got b squared minus 4 times that, that's 24 times the 3 is 24, that comes to 12. So it does intersect. Unfortunately, that's not a perfect square, so I won't be able to factorise it to get those zeros immediately, but then I'm not interested in the zeros either. And just all I want is what does the graph look like so I know where to start and stop it. Now, so I'm not even interested if that's at 3 particularly. Now it says it only goes from 0 to 2, and at 0, so this part doesn't exist, that's not included, so that means at 0 there I should really have a hollow point. It goes as far as 2, but where is 2? Well, maybe if I find this turning point first. Now to find that turning point there, that minimum turning point, you can either differentiate it, or complete the square. Maybe for a bit of fun I'll just complete the square. So what have I got? I've got 2 times, if I just take the first 2 term ignoring that 3, I've got 2 times x squared minus 3x, and there's the 3, and now I can form a square, so that must be x, and that must be half of that 3 upon 2, squaring it back up, 9 upon 4, that's 9 upon 2 added on, minus 9 upon 2, 6, that's minus 3 upon 2. So I've got that turning point, 3 upon 2, negative 3 upon 2, or if you like 1.5, negative 1.5. So that's going to be the point 1.5, negative 1.5. Now where's this 2 though? Now, I don't really want to work out the zeros, but I won't need to. All I'll do is I'll just work out what 2 comes to. What's the value of this function at 2? Well, it's going to be 2 times 2 squared minus 6 times the 2 plus 3. So it's just going to be the 8 minus 12 plus the 3, so that's just going to be negative 1. So it's at 2, negative 1, which means at 2 I'm still below. So 2 must be about here somewhere. That's the point, 2, negative 1. So that's the graph of this function on that domain, just this little portion here, including that point, but not including that point. Now I can say, what are the critical points? Well, the critical points are simply any point that's interesting as you move along the curve. And the only interesting points would be where you start, where you finish, where you turn. That would be interesting if it was there, but it's not there, so I can't mention it. So the only 2 points I've got of any interest are this turning point and this end point. So critical points, I don't want to put negative, 1.5, negative 1.5, and 2, negative 1 for the critical points. That was the first part. Now the next part said, what about the local significant points? Local maximum, local minimum. Well, as far as a minimum value is concerned, this is a minimum, and it's certainly a local minimum meaning in its neighbourhood, in its locality, it's smaller than anything in either side of it, and there has to be both sides to compare it to. So that's certainly a local minimum. I'm not sure if I'll mention it just now because it's got another title that would supersede it. What about a local maximum? Well, the highest value would be up here, but then that would again be a global maximum, but this doesn't exist anyway. So the only other contender for a bigness for a maximum is this point here. But it can't qualify as a local maximum because in its locality, if you were standing on the point, I can't see it's bigger than anything on either side of it because it's one-sided. So the only thing I can see in this category of localness would be I have an endpoint maximum. There's an endpoint maximum at 2, negative 1, but it's not a local maximum. There isn't anything on this side. Now, part C was a bit global, meaning overall, and this was where it can gain its true crown. Yes, I've got a local minimum there because it's bigger than it's lower than anything on either side of it, But again, overall, out of the whole domain, it's the lowest overall. So I've got a global minimum at 1.5, negative 1.5. What about a global maximum overall? Well, that's certainly no use. It was sort of like a maximum in its locality, at least an endpoint maximum, but the answers were far bigger over here. But unfortunately, this point here, which would have been the contender for the global maximum, doesn't exist. So I'll just have to say there's no global maximum. And that would be it. I've only got these two critical points, and the only two that are worthy of a name are those two. That one was an endpoint maximum, and that one was a global minimum. That would be question 2.